Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all. And in this lesson, we're going to be answering the major underlying topic being what exactly are polynomials. Now, before we get into the lesson, please make sure to do 4 things. Make sure to hit that subscribe button, turn on post notifications, hit that like button on this video, and also feel free to leave a comment down below. As I was saying, the main topic and underlying theme of this lesson is going to be our formal introduction to polynomials and identifying their basic functions by looking at their properties. As you can see here, p of x, that's just a basic example of polynomials, but don't worry if you're intimidated, we're going to break this down step by step, identifying the basis and key factors. So let's start off with a very important term in this intro to our polynomials. It's called our monomial. So the monomial is the basis of polynomials, what we're going to be talking about all throughout Algebra 1. So a monomial is a real number, a variable, or the product of real numbers and one or more whole number exponents. So the way that I like to think of monomial, just to summarize everything that I've said, is I like to think of it as a single term, essentially. Any single term that doesn't have any operations other than multiplication between itself. So if you think about this, mono means one. Essentially, we can infer that the rest of this term, meal, that essentially means term. So in this case, we're referring ourselves to only one term. Say, for example, real numbers, 1, 2, 3, 4. Variable, x, y, z, so on and so forth. Or the product of real numbers and one or more whole number exponents. So if you think about it like 3 squared, or it could be 3x squared. Exponents combined with these real numbers and variables, all of them mesh together. 3x squared, say, for example, doesn't have any addition, subtraction, just 3x squared, one term on its own. So some examples, like I showed you, was like, say, for example, a natural number, a real number, 5. Then you have 3x, a variable and a real number. And then you have a combination of real number, exponent, and variable, negative 2y cubed times x. Now, obviously, the only thing connecting these things together are multiplication. There's no addition or subtraction. So therefore, it's going to be one singular term. Then another important aspect of this is the degree of the monomial. That's essentially the sum of the exponents of the variables of the monomial. So if you look at all the variables in that monomial, you just add those, you add their exponents up, and you get your degree. So let's calculate the degree of our monomials. So in order to calculate for the degrees of a monomial, you'd merely add the exponents of all the variables. Remember, the key term is variables here. And the reason why we're only adding the variables is that constants, our regular terms like numbers like 1, 2, 3, 4, so on and so forth, they have an exponent of 0. Now, the reason why they have an exponent of 0 in a polynomial is because they can be written as ax to the 0. Say, for example, we have the number 8 here. This can be rewritten as 8x to the 0. In order to keep consistent, because remember, polynomials, that includes all of our variables. So in this case, it's x to the 0. X to the 0, anything to the 0 is going to be 1, so therefore this equals 8, so just 8. So that variable that's attached to it is going to have a degree of 0. Therefore, it's going to have a total degree of 0. So we have 5x squared here, say, for example, our monomial. And as you can see here, we're going to take that 0 from our 5 and that 2 from our x squared. 0 is going to obviously just drop out because it's a constant. And obviously the only thing that's left is our 2, our exponent of 2 from x squared. So our degree is going to be a second degree. Then, of course, on the right-hand side here, we have 3x cubed times y, 3x cubed yz to the 4th. So essentially here, y times z to the 4th. So here what we're going to do is just going to add all of the exponents out. So I'm going to write out all the invisible exponents, just as an example. So 3 here, that's just going to have an exponent of x to the 0, so that would cancel out there. We have x cubed, so that's obviously an exponent of 3. Y, remember, variables, they do have an exponent. And any singular variable like y, x, that's going to have an exponent of 1. It's just going to equal itself again at the end of the day. So this y right here is going to have that exponent of 1. And obviously our z here is going to have that exponent of 4. So we're going to add up these 3 exponents, the 3 exponents of our 3 variables. That's going to be 3 plus 1 plus 4, and that's going to give us a total degree of 8. So this is going to be the 8th degree, essentially. An 8th degree monomial. So in terms of our polynomials, we're going to look at polynomials and their degrees and how exactly they build up off of our monomials that we looked at. So a polynomial It's the sum or difference of two or more monomials. These are also called terms, like I said. Monomials are essentially just your singular terms, like numbers and just groups of variables that are just multiplied together. That's a single term. Now, a polynomial is essentially when you take those monomials and you're adding or subtracting and adding some sort of operation in between them, either addition or subtraction, obviously. So the degree of a polynomial, like we looked at for monomials, it's going to be a little bit different. This is going to be the term with the greatest degree. So essentially, this is going to be the term with the greatest exponent. That's going to be the degree of the whole entire polynomial. So let's take a look at this polynomial right here. It has 4 terms. It has 4 monomials. Each one of these terms right here, 7x, 3, negative y, negative 3, negative y, and also our 2z right here, plus 2z. That's going to be 4 different monomials. Now, for a polynomial, remember, anything that's not a monomial is going to be considered our polynomials in this case. So in this property here, so we're looking at the highest degree that we have here. So 7x, we see a variable here, that's going to be 1. We see another variable here, negative y, that's going to be negative y to the first. Then obviously 2z, that's going to be 2z to the first. Now we're going to see what's the largest exponent that we have here. Well, it's basically spread throughout. That's just 1. So in this case, this would just be a first degree polynomial. A little bit different in terms of rules as compared to monomials. So it's very important to know that. All right, now let's take a look at polynomials in standard form. A very efficient and also a very kind of considered the proper way of writing your polynomials. So it's the default of what you should really write your polynomials in because it helps with your operations. So let's write the following polynomial in standard form. So what exactly is standard form before we actually take on this polynomial right there in front of us? So the standard form of a polynomial is the form of a polynomial in which the terms are written in descending order according to their degree. So essentially what we're saying is the degree of a polynomial, or a monomial in this case, within a polynomial is its exponent. So we're trying to write it in descending order from the largest exponent, a monomial, to the smallest monomial with the least exponent, essentially. So greatest exponent to the least exponent. That's what we're trying to do here. So we're going to rearrange this. Obviously, this isn't already in standard form, so we're going to start by taking the one with the largest exponent. So this is our first monomial with the largest exponent, 2z to the 7th. So that's 2z to the 7th. Then afterwards, what we're going to do is we're going to look at the next largest. That's going to be negative y to the 5th, because that 5 is going to order that right behind 7. Then obviously it's our 7x squared here. That's one whole term. We're taking the whole term that's multiplied to each separate variable, not just, x squared and leaving out 7. That's not how it works. So negative 3, obviously, is its own term. And here it's going to be a constant. It's going to have technically a degree of 0. So that's going to be minus 3. That's how we're going to write it in standard form. Pretty simple, and it will help you out a lot when we start to do operations like addition, subtraction, multiplication, division with all our polynomials. Now let's take a look at variations of polynomials. So this is going to be a table of polynomial types. I'm going to give you all the different types of polynomials that you can have and how to identify them based off of the amount of terms that they have and also the degree that they have. So there's 2 identifications that you have with a polynomial. You say, for example, you have 2 terms within a polynomial, and then you're trying to find out the degree. You always identify it by the number of terms and the degree of the polynomial. So in this case, we have all of our terms included on the screen here. So that's going to be a term, it's going to be on the left-hand side. What are the terms that we're going to be identifying here? And then obviously the degrees, the degree name, terms, and the term name. So the degrees. Essentially, what is the degree of each term? So 7 right here. 7, we can merely rewrite this as 7x to the 0. Remember, that's our basic proof, just like you would do in geometry. So 7x to the 0, we know that all constants have a degree of 0. The name of this would be considered a constant here. Constants always have a 0 degree. Therefore, any numbers, single numbers, no variables, are going to be considered constant. The number of terms is going to be essentially what we're identifying here. So it's going to be essentially a single term. It's going to be 1. And the type of term, so essentially the type of term name, is going to be a monomial. So if we only have 1 term, that's just going to be a singular monomial. Then afterwards, we're going to take a look at 12x here. Now, there's an added variable here. That's the one major difference. So we're going to obviously add in that invisible exponent of 1, making it, the identity property. Essentially, it's going to stay the same. The number of degrees here. Now, remember, variables all have 1 degree. There's only 1 variable, so it's going to be a first degree. The degree name of this would be a linear polynomial. Linear type of polynomial. That's because it's a first degree. Anything first degree is linear. The number of terms is obviously going to be 1. It's still a monomial. So in this case, this would be a linear monomial. The first one would be a constant monomial. And then obviously here we have x squared minus 4. Now we've added in an increased exponent. Our exponent has essentially increased. And also we have a separate term. So we have x squared here, and we have 2 separate terms. So in terms of our degrees, that's going to be a 2 here, because that's our largest. Because remember, only for monomials do you add up the degrees, but for anything greater, you're always going to see the largest. So squared here, obviously the degree name, that's merely going to be, in terms of our degrees, that's going to be a quadratic, because it's squared. If you look to your quadratic equations, that all has x squared in it. So that's where the square for quadratic really comes from. Then the number of terms, that's just going to be 2 terms. And this is something interesting. The term name for this polynomial is actually going to be a binomial, because it has 2 monomials. Think of bi as 2, so it's going to be a binomial, specific type of polynomial. Then, of course, x cubed plus x squared minus 4. In this case, we're going to see how many degrees this essentially has. But remember, only for monomials do you add it up. Anything else, you're going to look for the largest amount of degrees. So largest degree measure. Here is our largest degree right here. So that's going to make our degree 3 here. That's going to make this a cubic polynomial. Obviously, the number of terms here, it's changed as well. We've upped the ante to 3 different terms. That's going to make this a trinomial. We're increasing the number of terms as well. And there's 3 terms, therefore, the prefix of tri. And lastly, we have this more complex expression here. X to the 4th plus x cubed plus x squared minus 4. That's 4 different terms here. And also we can identify this as a specific type of polynomial, and also we're going to look for the largest degree measure. So the largest degree measure is x to the 4th in standard form. It's easy to find out with standard form. That's why we always write it in that way. So the degrees is going to be 4, our largest exponent. The degree name of this is essentially going to be you can consider this your quartic function. And then also the term numbers are going to be, you're going to have 4 terms in this case. Because it's 4 different monomials in this case as well. And then the term name for this would actually be a polynomial. Oh, I'm sorry. For the quartic, it should actually be cubic. That's when you have x to the, sorry, no, it should be. I apologize. Yeah, that's going to be a quartic function here. Because of the degree being to the 4th power, essentially it's called a quartic. You can just write this as 4th power to the 4th power. But as you get into higher level math, you'll realize that the professional way of calling this is quartic right here. As you get on, say for example 5 and 6, 5 is going to be, you have your quartic functions, then you get on to 5 and 6, and you start to learn those larger functions. Therefore, just giving you a little, example that's going to be quartic for 4, something that you probably didn't know before. And this is all related to Greek roots. Think about tri, 3, that's going to be, a cubic function, and then quartic, qua, QUA, that's something that you find in some things like, quadriceps, and also, quadrinomials, you can call this. Anything with QUA essentially as the starting root prefix, that's going to be 4. So just examples like that. All right, everyone. Well, I hope you enjoyed this video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Check out our website at www.ecoreacademy.org. We have full free materials there to help you learn. Also, email us at eCoreAcademy@gmail.com and check out all of our socials. This has been AJay Raj. I hope you guys enjoyed this video, and I'll see you guys in the next one. Peace.